Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin, and I'm going to cover Bernoulli's equation today. So the differential equation of the form dy dx plus p of xy equals f of x times y to the n is a differential equation called Bernoulli's equation. Now, if n is equal to 0 or n is equal to 1, the equation is linear, and we can just use the integrating factor to solve. Otherwise, we use the substitution. U is equal to y to the 1 minus n, of course, where n is going to be this power on the y. So what I want to do is I want to solve this differential equation here. And the first thing I need to do is I need to put it in this form. And what I can tell you is that the coefficient in front of dy dx has to be equal to 1 and not this x. So I'm going to divide everything by x. So dy dx is going to be plus, 1 over xy is equal to, now dividing this by x, we're going to have xy squared. Now let's have that form, dy dx, a function of x times y, and another function of x times y to a power. Now, since n is not equal to 0 or 1, we use the substitution. So we're going to use u, which is equal to y to the 1 minus this power, which is going to be equal to 2, or this is going to be, y to the negative 1 or 1 over y. And then I can solve this thing for y and say y is equal to 1 over u. Now, I'm not just going to substitute for y, I also have to substitute for dy dx. And the real goal of this Bernoulli equation is, right now I cannot solve it because it's not a linear differential equation using that integrating factor. But if I substitute using this substitution, it's going to turn this nonlinear differential equation into a linear differential equation in terms of u and x as opposed to in terms of y and x. So then you can use that integrating factor to solve your solution function, which in this case will be u. And then you can unsubstitute using this to turn it back into y's. All right, so let's do that substitution and let's turn this thing linear. So what I know is that dy dx is equal to dy du times du dx using the chain rule. You can see like the du's kind of cancel, so these two things are the same. So I know y, so I also know dy du. So dy du is going to be the derivative of this. So this is u to the negative 1. So this is going to be minus u to the minus 2, which is going to be equal to negative 1 over u squared. So that means, dy dx is going to be equal to, dy du, so minus 1 over u squared times du dx. And that's equal to dy dx. So we're going to substitute our y's and our dy dx's. So dy dx is this over here. So minus 1 over u squared du dx plus 1 over x. Now y is equal to this thing, which is equal to 1 over u, so times 1 over u. And this is going to be equal to x times, this thing squared. So y squared is 1 squared is 1, u squared is u squared. So this is going to be times 1 over u squared. Now, in order to turn this into a linear differential equation where you can use the integrating factors, again, I don't need a coefficient of this function of u. What I need is a coefficient of 1. So we're going to multiply everything by negative u squared. So that means du dx plus 1 over x. Now, when I multiply this by negative u squared, I'm going to have a u squared in the top, a u in the bottom, so it's just going to become u, and this is negative, so this will be a minus u. Now, if I multiply this by negative u squared, the u squareds will cancel, but I'm still going to have that negative. Now, this is a differential equation, a linear differential equation where I can use the integrating factor, and that integrating factor is going to be found by, finding this. So the integrating factor is going to be equal to e to the integral of p of x dx, where p of x is this coefficient function in front of our solution. So this is going to be equal to e to the integral of minus 1 over x dx. So this is going to be equal to e to the natural log of, well, actually I have to, this is going to be minus the natural log of x. And when I put this x, the negative as a coefficient, when I put it into the power, this is going to become e to the minus 1 over x. That's not right. Let's try that again. This is going to become e to the natural log of 1 over x, which is going to equal 1 over x. Now what the integrating factor does for us is if I multiply everything by this integrating factor, this left-hand side is going to become the derivative of something. So du dx minus 1 over x is going to be 1 over x squared times u, and then multiplying this by 1 over x is just going to become minus 1. Now the claim is that this thing is now the derivative with respect to x of our integrating factor, which is 1 over x, times, well, your solution function, which is going to be equal to u. And we can double check that. Derivative of the first right here times the second plus the first times the derivative of the second. Indeed, it is the product rule of these two things. And this is equal to -1. So now in order to get rid of this derivative, to isolate what's inside, is I integrate both sides. Let's do that in the color. So what I'm going to do is I'm going to integrate this side with respect to x, integrate this side with respect to x. So what we say is that 1 over x times u is going to be equal to the integral of this with respect to x. So this is going to be minus x plus c. So then I can solve this thing for u. So u is going to be equal to minus x squared plus c times x. Now remember, this is the solution in terms of u. I want this in terms of y, so what I can do is I can unsubstitute. U is equal to 1 over y. So 1 over y is equal to negative x squared plus cx. And cross multiplying, we can isolate our y. So negative x squared plus cx is equal to y. And this is the solution to that differential equation. So let's do one more example that's a little more challenging. And that'll be it. So this is the differential equation I want to solve, and the first thing I want to do is put it in Bernoulli's form. So let's go ahead and distribute over here. So this is going to be 2xy to the fourth minus 2xy. And now I'm going to send everything to the other side. So this is going to be 3 times 1 plus x squared dy dx plus 2xy is going to be equal to this 2xy to the fourth. And this is similar to what we had as far as the previous differential equation. So dividing everything by this coefficient, so I can figure out what that is. So we're going to have dy dx plus 2x over 3 times 1 plus x squared y. And this is going to be equal to 2x all over 3 times 1 plus x squared y to the fourth. Now this is a Bernoulli's form. I know that the power is going to be 4, so using our substitution, the substitution is going to be u is equal to y to the 1 minus n, so n is 4, so u is going to be equal to y to the 1 minus 4, or this is going to be y to the negative 3, or y cubed in the denominator. So if u is equal to 1 over y cubed, then y cubed is equal to 1 over u, saying that y is going to be equal to cube rooting both sides. This would be u to the 1/3 power. Now remember that we also have to find your dy dx in terms of u as well. And what we know, again, is dy dx is equal to dy du times du dx. So if I take the derivative of this piece, remember this is u to the negative 1/3. So dy dx is going to be equal to the derivative of this thing, so minus 1/3 u to the minus 4/3 times du dx. So if I write this in another form, I'm going to have minus 1 all over 3u to the 4/3 of the denominator times du dx. All right, so this is your y, this is your dy dx. We're going to plug them in over here. So we have minus 1 over 3u to the 4/3 times du dx plus, I'm going to have to multiply, well, this is going to be plus 2x. I'm going to multiply this by y, but our y is given by this. So y is going to be equal to u to the negative 1/3, or I'm going to say 1 over u to the 1/3. And similarly, I have a y to the 4th, so 2x all over 3 times 1 plus x squared. And our y to the 4th power, I'm going to, 4th power this, which really means 1 to the 4th is 4. U to the 1/3 of the 4th is going to be u to the 4/3 on the bottom, so this is going to be 1 all over u to the 4/3. So finishing this off, I know that I have to have a coefficient of 1, so I'm going to multiply everything by this coefficient. So du dx is going to equal, well, multiplying by negative 1/3 u to the 4/3 in the denominator, so u to the negative 4/3, to each one of these pieces. Well, this is going to turn negative because it's positive. I'm going to have this 2x over 3 times 1 plus x squared. And remember that we're going to have this, this 3 u to the 4/3 over u to the 1/3 equals 2x all over 3 times 1 plus x squared. And then I'm also going to have that minus 3 u to the 4/3 all over just u to the 4/3. And we'll see some things, work out nicely. So we can see that these 3's are going to cancel. These u to the 4/3 are going to cancel. Those 3's are going to cancel. So this over here is going to be on the right-hand side. We're going to have negative 2x over 1 plus x squared. And on the right-hand side, on the left-hand side, I'm going to have du dx is going to equal 2x minus 2x all over 1 plus x squared. And this u to the 4/3 divided by u to the 1/3, I subtract their power, so 4/3 minus 1/3 is going to be 1. So this is just going to be equal to u. And really to kind of show you, is this working? Am I doing this correctly? Well, the problem is when you're looking at this differential equation, or even this one right here, I have this y to the 4th is what makes it nonlinear. So, over here I have a function of 2 variables, and now it is gone. There's not an extra function over there. This is just a function of x. So, and we're looking good here. So now I have to find the integrating factor. So our integrating factor is going to equal e to minus the integral of p of x. So it's going to be this coefficient function, 1 plus x squared dx. And I got to make a substitution here. So let's say r is equal to 1 plus x squared. So then dr is going to be equal to 2x dx. So this is equal to e to the negative integral of 1 over r dr. So that would be equal to e to the minus the natural log of just, well, absolute value of r, but r is 1 plus x squared. So I can put that at the bottom. This is going to be equal to e to the natural log of 1 over r, which is which is 1 over r. And x squared plus 1 is positive as y. So this is 1 over 1 plus x squared, which is what we get for our integrating factor. So multiplying everything by that. So if I multiply everything by 1 over 1 plus x squared, we're going to see that this left-hand side is the product rule of that integrating factor and your solution, which is u. So 1 over x squared, made that power on the bottom too, so I have 2 factors of 1 over x squared on the bottom. The same thing here, I got 2 factors of that 1 over x squared. So this is the derivative with respect to x of the integrating factor, which is 1 over 1 plus x squared, times the solution, which is going to be equal to u. Now, again, what I can do is I can integrate both sides with respect to x. And a lot of times it's helpful to double check the derivative of this. This derivative of this is, so derivative of this times this plus this times the derivative of this. So we're good. We are good here. So now I'm going to do the integral with respect to x. Just making sure that when I do the power rule, I get this thing back. And then also, sorry, the integral of this with respect to x as well. So let's erase. You know what, let's just make a note. I'm going to make my substitutions up here. So I know that u is equal to 1 over y cubed. That's the only thing I really need. So let's just kind of save that and then give ourselves some room when we're trying to integrate this. Because remember that this is going to give us a solution in terms of u, but I need it in terms of y. Okay, so back up here I'm going to have, 1 over 1 plus x squared times u, because the integral of the derivative will go away. Cancel that. And then over to this side, we're going to have to take the minus the integral of 2x all over 1 plus x squared dx. And it looks like this is going to have to be done by substitution again, and the same substitution, r is going to be equal to 1 plus x squared, so dr is going to be equal to 2x dx. So this thing becomes minus the integral of 1 over r squared dr. So this is going to be minus the integral of r to the minus 2 dr. So this is minus r to the minus 1 over minus 1, which is just going to become 1 over r. So this thing's integral is going to be equal to, make sure I got everything here, all the pieces are good. So r is going to be equal to 1 over 1 plus x squared, and don't forget our plus c. All right, and that is equal to, the left-hand side, which is 1 over 1 plus x squared, times our solution, which is going to be equal to u. Now our job is to isolate this u. So u is going to be equal to, multiplying everything by 1 over 1x plus x squared, I'm going to get 1 plus c times 1 plus x squared. Now this is a solution in terms of u. I need to unsubstitute here to be able to find the solution in terms of y. So 1 over y cubed is equal to this. And then similarly, we're going to cross multiply. So I have 1 over this 1 plus c times 1 plus x squared is equal to y cubed. And in order to get rid of that cube is we're going to cube root both sides of these. So this is the solution to that differential equation. So if you like the content, please subscribe.